Hello dear students, this is Vishal sir from Ikra High School. Today we are going to study chapter 1 from standard 10th subject science. The chapter that we are going to study is chemical reactions and equations. Now let us consider some examples given over here. We come through all these examples in our day-to-day life. The milk that is left at room temperature during summer changes its states and becomes sour. The iron tawa or the pan or the nail which is left exposed to humid atmosphere gets corroded. The grapes do get fermented. The cooked food tastes better than its raw food. The food in our body gets digested due to the digestive juices. When we respire, there is an exchange of oxygen gas and carbon dioxide gas in our lungs. So, in all the above situations that you have gone through, we find that the nature and the identity of the initial substance have somewhat changed. That means it has gone through the changes that occurs due to chemical. So, we will consider these changes as chemical changes. As you know, in chemistry, we have already studied about physical change and chemical change. Physical change means the changes that occur in a substance without changing its properties. While in a chemical change, a totally new substance is formed with new properties. So here we are going to study about the chemical changes. But if you want to learn about chemical changes, you have to go through an elaborated way which can only be understood by a chemical reaction. A chemical reaction gives us a brief idea about the chemical change that has taken place. So, what are these chemical reactions? The chemical reaction involves the transformation of one or more substance into another substance or substances. It involves a change in composition and is represented by a chemical equation. Now let's go through some examples which gives us an elaborated idea about how a chemical reaction occurs. Here if you see in activity 1.1, a magnesium ribbon of 3 to 4 centimeter long is been rubbed with a sandpaper. Then after that it is held with a pair of tongs and burnt it using a spirit lamp. When it burns with a dazzling flame. And you can see here after burning it becomes white powder, that is magnesium oxide. So here if we observe that the magnesium ribbon burns with a dazzling white flame and changes into a white powder. This white powder is magnesium oxide. How it is formed? It is formed due to the reaction between magnesium and oxygen present in the air. So here we can observe or we can see one chemical reaction happening in front of us. We still have many activities to understand that. Let's go through activity 1.3. In activity 1.3, you can see that a flask is filled with some acid. It may be dilute sulfuric acid or even hydrochloric acid. After that, some zinc granules are added to it, which conducts a chemical reaction. Here, the temperature of the flask also rises as the reaction takes place, and the hydrogen gas is also evolved. So, from the activities, we can say that any of the following observation help us to determine whether a chemical reaction has taken place. There are certain changes that happen during a chemical reaction. It can change its state, even the color of the substance can change. There may be evolution of a gas or a change in temperature. So these are the four conditions through which we can say that a chemical reaction has occurred. Now, the chemical change involves a change in composition and it is always represented by a chemical equation. So when you want to describe any chemical change or the chemical reaction, you can describe it through a chemical equation where we can understand the reaction properly. Let's go through the example once again. What happened when the magnesium ribbon was burned? It converted into magnesium oxide. This description of chemical reaction in a sentence form is quite long. So here you can see you have written a long way to understand a chemical reaction. It can be understood in a concise manner also. It can be written in a shorter form. Here the simplest way is given to you. That is what we called word equation. So instead of using the whole sentence, we will use the words or the substances that have taken part in a chemical reaction. You can see over here the word equation seems something like this. Magnesium when reacts with oxygen, that means when magnesium was burnt in air, it formed magnesium oxide. Now this is what we called chemical equation. The substance that undergoes chemical change in reaction 1.1, magnesium and oxygen, are the reactants. So on the left hand side of the arrow are two substances, magnesium and oxygen, and these are called reactants. That means they react to form a new product with totally new properties. The new substance is magnesium oxide formed during the reaction as a product. The word equation shows change of reactants to product through an arrow placed between them. The reactants are written on the left hand side with a plus sign between them. Similarly, products are written on the right hand side with a plus sign between them. Here you won't find any plus sign because only one product has evolved. The arrowhead points towards the product and shows the direction of the reaction. That means this arrow shows that when these two reactants reacted, it formed a new product and the product is in the direction of the arrow. Now as we have gone through, the chemical equations are representations of chemical reaction in terms of symbol of elements and formulas of compound involved in the reaction. The substance that enter into a chemical reactions, what we call reactants, and the substance which are formed from that reactions are what we call products. Now let's go through the process how a chemical equation can be written in a proper manner. The chemical equation can be made more concise and useful if we use a chemical formula instead of words. So instead of writing the whole word magnesium, we can simply write its chemical formula. If you go through here, a chemical equation represents a chemical reaction, and here you can see the formula for magnesium oxygen and magnesium oxide. It can be written like this: Mg, that is magnesium, plus O2, that is oxygen, and MgO, that is magnesium oxide. So this is a way shorter form to write a chemical equation. Now let's count and compare the number of atoms on each of the element on the left hand side and right hand side of the arrow. Here you can see magnesium is having one atom. On the right hand side also it is having one atom. On the left hand side, oxygen is having two atoms. Here you can see a subscript is written over here, 2. But on the right hand side, oxygen does not have any subscript. That means there is an imbalance in the equation. Such chemical equations without any balance are called skeletal chemical equations. So these are written just to understand what elements have taken place the reaction. But this is not the correct form to write any chemical equation. For this, we need to balance the chemical equation. That means on the left hand side and the right hand side, the number of atoms of any particular element should remain same. Now, here you can see, according to the law of conservation of mass, mass can neither be created nor destroyed in any chemical reaction. That is, the total mass of the element present in the product of a chemical reaction has to be equal to the total mass of element present in the reactant, which explains us that the number of atoms on each element remains same before and after the reaction. That means we need to balance a skeletal chemical equation. Now, how is a chemical equation balanced? We have to understand it through some examples. Let's go through the example given over here in the textbook. You can see that zinc and sulfuric acid, when reacts, gives zinc sulfate and hydrogen gas. Now, if you write it in a chemical formula, it will be written something like this. For zinc, the formula Zn, sulfuric acid H2SO4, zinc sulfate ZnSO4 and hydrogen H2. Now let's count the number of atoms on both the side, on the left hand side also, that is here in the reactant also, and on the right hand side, that is here on the right hand side. So here they have made a table, and you can see the table with elements zinc, hydrogen, sulfur and oxygen. On the left hand side, zinc had one atom. You can see over here, it's only Zn. In the same manner, on the right hand side also you can see one atom. For hydrogen, you can see it is written H2. That means two atoms of hydrogen are there. On the right hand side, it also maintains the same thing with two hydrogen atoms. For sulfur, 1 and 1. Right hand side 1, left hand side also 1 atom. For oxygen, 4 atoms and 4 atoms. That means the whole equation is balanced. If you go through the table, you will find no change on the left hand side and the right hand side of all the atoms. It maintains its atomicity. So, this equation of zinc with sulfuric acid is a balanced chemical equation. Now let's go through one more example. Here you can see iron reacts with water to give iron oxide and hydrogen gas. So here again we have to prepare a table to check whether the equation is a balanced equation or not. On the left hand side you can find iron with one atom, while on the left hand side it has increased to 3 atoms. Hydrogen on the other hand maintains its atomicity, maintaining both 2 atoms on left hand side and the right hand side, while there is also an imbalance in oxygen atom, while it is 1 on left hand side and 4 on right hand side. So here in the table you can clearly observe that iron LHS 1, while in RHS it has 3 atoms. Hydrogen remains same, while oxygen has 1 atom in left hand side, that is in the reactant manner, and 4 in the product way. So to balance the equation, it is more convenient to start balancing with a compound that contains maximum number of atoms. Here the maximum number of change in atom is oxygen with 4. We have to start balancing the oxygen first. It may be a reactant or a product, it may be anywhere, but you have to start with the element having maximum difference. Now let's see how to balance the equation. To balance the oxygen atom, you can look in the table. Initially, that was the first, it had one atom in reactant while it has four atom in product. So here to maintain 4 in reactant we have to multiply it with 4. So that will equalize the number of atom, and it must be remembered that we cannot alter the formula of the compound or element involved in the reaction. The formula will remain as it is, only the number of atoms can be balanced. So to balance a chemical equation, the 4 should be written something like this over here. 4 2s are 8 hydrogen, now it becomes 8 hydrogen, while oxygen is become 4, and that maintains on the right hand side 4 oxygen. But due to multiplying 4 with water, we have one more imbalanced element, that is water. So now iron and hydrogen atoms are not balanced. Let's pick any of this. Here, let's talk about hydrogen first. Initially, hydrogen became 8 atoms in reactant, as it was multiplied over here, 4 2s are 8, while it remained hydrogen as 2. So let's multiply 2 in the product to make it 8. Here you can see instead of H2 we wrote 4H2. Here also 4H2. 4 2s are 8 hydrogen on the left hand side, as well as 4 2s are 8 on the right hand side. Also, because of keeping this 4, we got a balanced oxygen in both the reactant and the product. Now we are only left with iron as imbalance. So it was 3 in the product, Fe3, and 1 in the reactant. Let's multiply 3 in the reactant. So now the equation would seem something like this. 3Fe, that is 3 atoms of iron, will give you 3 atoms of iron in the product. 4 2s are 8 atoms of hydrogen in the reactant. 4 2s are 8 atoms of hydrogen in the product. 4 1s are 4 oxygen in the reactant and 4 oxygen in the product. So finally, we got the correct form of the chemical equation. So that is 3Fe plus 4H2O gives Fe3O4 plus 4H2, and this is a balanced equation. The method that we have gone through to balance the chemical equation is known as hit and trial method. So we make trials to balance the equation by using the smallest whole number coefficient. Now there are still more things that we need to keep in mind while writing a balanced chemical equation. Now the other things that have to be mentioned in a chemical equation is writing the symbols of its physical state. Here in the chemical equation you can see that the iron was solid, water here was gaseous, not the liquid form, it was gaseous form. Iron oxide that you obtained was solid, and hydrogen gas was evolved as a gaseous material. So these physical states are not included in a chemical equation unless it is necessary to specify them. Many times we have to consider the temperature, pressure, catalyst that took place during the chemical reaction also. In these two final equations you can find that they have written about how many atmospheric pressure should be there to conduct this equation in a correct way. Here also the formula for photosynthesis is given to you, where presence of sunlight and chlorophyll should be there to conduct the whole equation. So that should be written near the arrow.